Okay, so we had a few technical difficulties at the GBM, and I feel like you guys deserve better, so I wanted to make it up by creating this video where I just walk through the commands nice and quickly. So Linux is an operating system. Most of you are familiar with like Windows and Mac. Those are both proprietary. Linux, on the other hand, is open source, so anyone can make their own Linux operating system. And as a result, there's a bunch of different distros or distributions. As you can see, I'm using one called Pop! OS that's based on Ubuntu or Debian, both like very easy beginner friendly ones. It doesn't matter what you use, no matter which version, they all have something known as the Linux terminal. And this is going to show up everywhere in CS. So yeah, let's dig into it. Basically, let me zoom in real quickly so you guys can see the code better. You look at this, if you have no experience with the terminal, this is going to be scary. So let's start with some basic commands for figuring out what's going on here. Okay? This is the terminal. It's similar to, you know how you have your file system on your device? So your device is a GUI or graphical user interface. And it's nice and pretty. We can click stuff. It makes sense. And we have folders that we can click into and do stuff. But the problem is when you have a lot of stuff going on or you need to do things really quickly, this isn't efficient. So instead we use a terminal where instead of pictures, it's text. And instead of folders, we call them directories. So this is essentially a programming language for navigating folders. That's like an easy way of thinking about it. And specifically, in my case, the programming language, so to speak, that we're using is something called Bash, the born-again shell. There are a bunch of different ones, but Bash is the most common you'll see. So let's get started with figuring out what's going on. Like, you're looking at this, you have no clue, you're having an identity crisis. First thing you want to ask is, who am I? And you see, I am Pukey. I am the user Pukey. And as you can see, that matches what it says up here, right before the at. But what's this other part right here? Well, that's the host name. The host name is Pop! OS. So I am the user Pukey on the machine Pop! OS. That's what that means. It lets you figure out who you are and where you are. Now, after that, we have this tilde here. And the tilde is special. Basically, after this, it tells us what folder are we in. And we don't call it folders, remember, we call them directories. So this is telling me what directory am I in. And if I want to figure out the directory I'm currently in, I'm going to print working directory. Boom. And you see here it says home Pukey. So inside the home directory, I'm inside the directory for Pukey because I'm user Pukey. But you notice here, it doesn't say that, it just shows tilde. Well, what does this tilde mean? We can figure out using a command called echo. Echo is really cool. It basically just, whatever you put in there, it echoes back. So I'm going to echo tilde. And you see it says home Pukey. So this tilde is actually something specific for each user. It's their home directory. As soon as they log in, they're going to go to tilde. Okay? So that's basic for figuring out who you are, where you are. But we also want to know what's in this folder, what's in my home folder. And to use that, we want to list the contents. So we're using the command ls. And you can see it prints all of the stuff in my folder, in my directory. This is my home directory. And as you can see, I have a bunch of junk in there. But anyways, let's do something special. This command can actually do a lot more than what you see right now. And the key is we need to use flags. So flags are special additions you can use to customize your command. For example, if I do tac A, that's the flag for all. It's displaying all of the things in my folder, in my directory. So as you can see here, we only showed some things. Here, we show a lot more thins. Why weren't these thins showing up before? That's because they're hidden. You can see there's a dot in front of all of these names. If you have a dot, that hides the file, so you can't see it. If you went into your file explorer and you tried to look for these, you're not going to see it. So that's one advantage to a terminal. You get a lot more access to a lot more information. It's a bit more difficult to do it using a GUI. So here, it displays everything. And you notice mine is color coded. Depending on your OS, the colors might be different, but for me, it's like this. Blank, regular white text, that's just a file. Blue is going to be a directory, so a folder that we can go into. Green is going to be a script that we can execute. And red basically means it's no longer valid. The red and the cyan we're going to touch on later, but let's hold that off for now. And instead, let's go back to our command ls. There's actually more you can do. There's another command, ls-l. This lists all of the properties of our files. And we can go and break it down bit by bit, but before I do that, I want to finish talking about commands. So we have ls-a we talked about, and ls-l. We can do both of them, and as you see now, it does both of them. It displays all and their properties. But I can also just combine the flags into one word, so al in this case, and it does the same thing as you can see. So if that's how commands work, and if you don't know what a command does, there's a few things you can do. One is basically every command has a help flag. When you do it, it gives you some stuff on how to use the command. Like we can see all of the flags here. Similarly, each command has something known as a man page, a manual. So if you do man ls, it'll pull up the manual for that file, right? And so we can just exit out like this. But for me, that's not really friendly. I don't like looking at that text. I much prefer just going to Google and Googling, hey, what does this command do? A really good website is explainshell.com. If you just go to this website, it's going to tell you what the command does and break it down piece by piece. But my internet's a bit slow, so while that's loading, let's go back here. Also, ChatGPT is pretty good if you want to. Anyways, back to AL. Let's break down what all of this means. So we have this section here. Looks like a bunch of random letters. We got numbers here. Two things. This looks like me. That's Pukey. That's me. And then we have some numbers here, a date, and then the name. So how this works is this part here is the user who owns that file. Typically, whoever made that file. Since I made all of the files here, you see me as the user. Here's the group. So each user is actually part of a larger group. And so we have users can do certain things, and also groups can do certain things. If you're a user in that group, you get certain privileges. But let's look at this over here, because it's kind of complicated. We have 9 spaces, okay? And we can break it up into chunks of 3. So the first 3, the second 3, and the last 3. If you know binary, I'm going to touch on that later. But for now, let's just explain it using letters. So here we show the permissions of a file, basically who can do what. And we break it up based on 3 different scenarios. Either you're the user who owns it, in this case Pukey, and we see you can read the file, you can write to the file, and you can execute that file, okay? So basically, monkey see, monkey can change, monkey can write, and monkey do. That's what these 3 things do. So that's for the user. So in this case, the user Pukey can read, write, and execute this file. The group Pukey can also read, write, and execute this file. And also anyone else who's not part of that. Any random person can read and execute this file. And so that's what that means. You also notice we have a D in front of you. You can figure out that's for all of our directories are indicated by a D. And sometimes at the end, you'll see like an I for a sticky bit. You don't need to worry about that. Basically, it means the file can only be changed by the person who made it. It's complicated. You don't have to worry. What really matters is getting these permissions down. Do you understand read, write, execute? Based on this, can you tell me who can do what? And the reason this is important is because when we're going into a system, we want to be able to do stuff, right? If there's a file with some juicy information, we want to know if we can actually read it. If there's a malicious binary, we want to know if we can make people execute it. So let's figure out how we can change permissions for a file. But to do that, I want to first make a dummy environment where we can do things safely. So I'm going to make a new directory that we can do stuff in. So I want to make mk directory, make door. And what do I want to name it? Let's do example, okay? And so now when we ls, you can see the example directory now exists. Now I want to go into that. I want to change directory to example. And notice I started typing. I can autocomplete by pressing tab, and it does it for you. Tab is wonderful. Enter, and now you see, hey, my position updated. I'm now here. And if I were to print working directory, you can see, oh yeah, I'm actually in that folder now. Now, two things. One, here we did something known as a relative path. It was based on where we currently are. But you can also do an absolute path, which means you start from the very, very beginning, the biggest folder possible, and write your whole way there. So this right here would be an absolute directory. I could do cd home pukey example, and it would take me also to this place. So you can see you can do relative or you can do absolute. Both are useful depending on the scenario. Usually relative is easier to type out. So now that we're here, let's look at what we have. ls, we see nothing. Let's do ls-a just to make sure. Oh, that's weird. We see two things here, a single dot and a double dot. But we just made this directory. How does it already have stuff in it? So the interesting thing about terminals is we need to be able to navigate and move around. So whenever we make a directory, we always have these two directories in it. The dot means the current directory. So in this case, dot is where we are right now. If I did cd dot, I'm in the same place. What about dot dot? That takes us one step back. So if I do cd dot dot, now I'm back at my home directory. And you can check to make sure, yep, that's my home directory. So let's go back into example. And I'll do the absolute directory here just for example. And now we're back here. So now that we're here, let's make a file. There's two ways to do this. One is by directly using a text editor, like Nano, but I don't want to do that. I want to use touch. I want to touch, let's call the file baby.txt. So you can see I've touched the baby. It makes the file baby.txt, right? So touch makes files. Make dir makes directories. Now let's check what's in this file. Actually, let's not do that. First, let's do ls-shell to see the properties of this file. Notice it was made by us, so Pukey is the user, and the group is Pukey, and its default permissions are read, write, and read. Okay, let's go into, also this number here I should mention is the size of the file. How much data does it contain? And right now it's 0 because we just made it. It's going to be empty. So let's go in there and edit that file to actually put stuff in it. Now there's a few text editors available. Obviously you can do Notepad if you want. That's actually I don't even have it. I just have text editor. That is an option if you want to, but let's not do that because that's still GUI really. Let's keep it to the terminal. So there's a few ones. If you're old, you can use VI. This is super old, and it was later updated into Vim. So we could do Vim baby.txt, and I actually don't have Vim on my machine, so we can't do that. I don't like Vim. You can do it on yours if you want, see what it's like. There's another one called Emacs. Emacs is also for old people. So I don't use Emacs either. What I use is Nano. Nano is pretty good if you're a newbie like me, because when you look into it, it's not as friendly as Notepad or text editor, but you can tell what's going on. They even give you commands down here to, like, how do you do these shortcuts? It tells you right down here. So all we have to do when we enter, we can just start typing. So we can say, hello, Adam. And then let's say this is line 2. And let's exit. So Control X, you can see down here, Control X is the command to exit. Yep, that looks good. And then just enter because I want to keep the name. And now let's look at our folder. Now we see this number has changed because we now have stuff in there. But how can we see the stuff in the file? Well, obviously we can use text editor, but no, I want to print it to terminal. I want to use cat. Cat prints the contents, as you can see right here. So cat means concatenate. It just takes everything in there and puts it together as a nice and pretty output that it prints out. So cat, super useful. So that's files, but let's do something more interesting. Let's make a file that you can actually run commands on, okay? This is known as scripting. Basically, a file that you can execute is usually referred to as a script. And so let's go ahead and make a script. Let's use baby.txt to make a script. So I'm going to go back into it, and we're going to make a few changes. First of all, very first thing, we're going to have our shebang is what it's called, because it's a hash and a bang bang. So together, shebang. Programmers like making up funny names for symbols. But anyways, this is our shebang, bin bash. So this line here basically tells us what programming language are we using. Here I'm using bash because that's the programming language of our terminal. Sometimes you might see other things like sh, I think, and maybe zsh. There's some weird stuff, but you can actually see like, oh, Python might be there, or maybe C++, who knows. But most of the time it's just going to be bin bash because we're working in terminal. Let's use the language built for terminals. So this tells us what language we're using. Now we can put the code. So for example, what if I wanted it to say some stuff to us? For example, echo hello Adam. And let's do echo line 2. And so now I'm going to save. And now if we just execute our command, we'll be able to see the thing. So to execute, you're going to do dot slash bb.txt. This is the notation for running a command. That's just how it works. And let's do it. Oh, permission denied. Why is that? Well, if you remember, these are our permissions. We can read and write, but we never gave execute permissions. So how are we going to do that? Well, one way is through the command chmod. It changes or modifies the permissions we have on a file. So I'm going to do chmod, and what do I want to do? I want to add execute. X is for execute, right? And I want to add that to baby.txt. And now if we do ls.shell, you see now all people have the execute permission, as you can see here. If I wanted to undo that, I could do chmod minus, let's do, I guess, yeah, let's just do execute again. And now we can see, yep, it's back to how it was before. So that's one way you can do it. I prefer a different way, and that has to do with binary numbers. So basically, let me use a different command. You don't see this one often. Adam showed it to me. It's really cool. This command basically prints it out to show you what I've been telling you, right? The file name is baby.txt, the owner is Pukey, the group is Pukey. Same information we had here, just structured nicely. And here are the permissions for the user, the group, and everyone else. Notice for each thing, there are 3 spots: read, write, execute. And it's either true, we have the thing, or it's false, we just have nothing there. We can also think of this as binary numbers. So this one would be 1, 1, 0. And in binary, 1, 1, 0, that's 4 plus 2, or 6. And same thing for the group, 1, 1, 0. Read, write is 6. And here it's just 1, 0, 0. So read is just 4. These are the permissions of our file. And so we can actually modify the permissions doing the same thing. So I said I want to give execute permission, but only for me. So only for user. I'm going to make this read, write, execute. So 1, 1, 1, which is 7. So that's going to be chmod 7 for the user. The group I want to keep the same, so 6. And other I want to keep the same, so 4. And of course baby.txt. Let's check it again. OMG, the permissions changed. We did it. And as you can see now, it's highlighted green because it's an executable. We can actually run it. And so let's run it. Oh, syntax error. I made an oopsie. Yeah, let's go back and check it. What's the oopsie? Oh, that's because I had semicolon. Semicolon means end line, duh. So I'm going to get rid of that. Let's do this instead. And let's check it. Now it works, right? Hello, Adam, line 2. Exactly what we wanted our script to do. So this is a powerful tool. If you're following along up to this point, you now have the power to automate anything you want to do. You can just make a script and have it go. It's wonderful. So let's talk about a few more details, okay? We were able to make a file, modify it, and make it executable. But notice that our file name .txt never changed. Right now it's not really a text file, it's more of a program, like a shell file. You might expect .sh, but no, it's .txt. Why is that? Well, in Linux, we don't care what the name is. It could be anything we want. For example, I could do baby.gugu gaga, and that would be a valid file name. This part after the dot means nothing in Linux. How Linux figure out the file type is based on the data in that file. If you're interested, look up magic numbers. They magically tell you what type of file it is. But anyways, this is how Linux works. The names may be misleading, but it gives us the ability to do whatever we want, which is kind of the whole trend in Linux. But anyways, let's get rid of that. So I'm going to remove the file. And now we see there's nothing in our directory. Could even do -A to show, yep, we have nothing there, just the regular directories to go back. So let's go back. And then let's get rid of that example folder because we don't need it anymore. I could do remove directory. Oh, I can't spell. And now you can see, yep, it's gone now. So that's how you remove things. You can use rm or rmdir. If there's a directory and you want to remove everything inside it, you can do rm-r because it's recursive, f to force it to remove no matter what. And then you type the thing you want to remove. Be very careful with this command because you might just delete everything on your computer. And guess what? When you delete everything on your computer, it breaks. So use this very carefully, okay? Okay. Great. Now we've talked about files. You know how to navigate, you know how to make files, do stuff. Great. Let's talk a bit more about users. So initially we logged in as the Pukey user, and there might be multiple users on the machine. Certain users, so let me step back a bit. There are many users on the machine, and the biggest user of them all, the big boy, is root. Root can do whatever they want on the machine. On a Windows, instead of root, I think they call it administrator. Administrator. But same thing. Basically, the user can do whatever they want. No one cares. That's very powerful. And you don't want anyone to just be able to be root. That would be pretty problematic, especially if someone's trying to destroy or attack your system. But certain users we trust and we give them special privileges. We give them the ability to become root whenever they want. Root is the super user, and when we want to do something as root, we can do super user do. Okay? Super user do, and then type whatever command you want. Typically, you do this whenever a command involves doing stuff to your machine. Like maybe you're installing a new service, something like that. I end up using sudo a lot. So let's just do a silly example you would never do, like sudo echo, which is pointless. It's just pointless. But you notice, when you do sudo, they ask you for your password. Duh, make sure you're you. So let's actually type in our password for this. Oh, wait a minute. I'm typing stuff. Why isn't anything showing up? Is my terminal broken? No, it's not broken. This is how it's meant to be. They decided that when you type your password, that's sensitive information. We don't want anyone seeing your password. So we'll just show nothing at all when you type your password. Duh, if there's nothing there, no one could peek at it and see what you're typing. So yeah, there's just nothing here at all. It's good security-wise, but it's kind of annoying if you make a typo and you're like, oh, maybe I messed up. So the trick is to, if you ever think you mess up, hold backspace for like 3 seconds until you're sure there's nothing there anymore. And then you can just start fresh and type your password. So let me do mine. And you see it's able to work. Now I can do it. Cool thing about sudo, after you do it once, your machine remembers, and now you can do it like over and over again without having to enter your password every time. So sudo is wonderful. If you're a bit spicy, you can actually become the root user. So I want to switch user, and now I'm root, as you can see. And I can just do stuff as root, but that's pretty dangerous because root can do anything. So I actually want to exit. I don't want to stay as root. I like being pukey. That's me. And if there's a different root, user on your machine, for example, Adam, I could do switch user Adam. And, oh, Adam doesn't exist. Yeah, duh, because I don't have him on my machine. It's just me. But anyways, that's users. Users also have groups that they're a part of. That's a bit complicated. One example of the group is... No, never mind. I won't talk about that. But groups are complicated, so I won't touch on that really. Basically, you can add people to groups, remove them from groups. It just gives you a bit extra permissions, you know. But that's that. What do I want to talk about next? Let's talk about... Let's do ls-l again, actually. No, not that. ls-a. There's one file in here that I like. Actually, two things I like. First, let's talk about this file, bashrc specifically. So I'm going to nano into bashrc and see what it is. And whoa, this is a lot of code. I don't really know what's going on, and you don't need to. Basically, this is for each user. They can run sort of custom commands specifically for them. And that's why it's in their bash RC, because bash is how you run commands. But basically, each user has certain special things. I'm going to point out two things that are cool. One, aliases, or alias, alias. No, alias, yeah, this is alias. So we have aliases. Alias basically says, if you begin a command with this word, instead, I'm going to replace it with this thing over here. So notice how when we did ls, it was always colorful. That's because it's not actually ls, it's ls, make it colorful. Okay, this flag makes it colorful. And we have an alias so that whenever we do ls, it automatically adds color to it. Nice. Here's another command that's cool, grep. I'll talk about grep later, but let's keep talking about aliases. You can actually add an alias to do whatever you want. So if I want an alias haha to actually say, oh, echo, you suck, I could do that. But I would need to save the changes. So this is the fancy command to save changes in our bash, only for our bash, because bash is special. But now I can do haha, and that's a command now, because haha actually means echo you suck. And so every time I type haha, it does that. Yay. But that's stupid. I'm gonna change it back. Oh, actually, yeah. Look at this. See, I'm pressing the up and down arrows, and look how it's just looking at my previous commands. That's a really cool thing about Terminal. It saves a history of all of the commands you've run. So if you want to ever quickly go back to a previous command, just press the arrow keys and you can get there. So for example, I want to go back to this command, bashrc. So let's see if I can get there. Yep, that's that. And I'm going to go back to where I was before. Yeah, let's just get rid of this. So I'm going to Control K to cut. And we're done. Anything else interesting here? Oh, yeah, path. So path, this is basically, when you see export, these are system variables. Basically, it's the same idea as an alias, except now, whenever you have this thingy in your code, it's going to replace it with this thingy. So typically, the most common example is path. Where do we find your executables? It's just a variable. And we can actually, Let me save those changes. You can actually see your path, I think, by doing echo $path. Let me see if it just works without the $sign. See, without the $sign, it just puts what I typed. But when I do put the $sign, it actually puts all of that stuff there. So variables you call using a $sign in front of the name. Okay? Okay, cool. Hopefully that made sense. Anyways, that's bash RC. Let's continue to another thing I want to talk about. Let me do ls-al again. These colors here, I said I would point out. This one's red, this one's cyan, and we both see, hey, they have arrows pointing to something over here. You also notice the file size is pretty small. Compared to the other things, that's pretty small. And if you notice, hey, 29, that's actually the size of this name. And 31 is the size of this name. Okay? Basically, what these two things are, what this arrow means, these are links, specifically symbolic links. Whenever we have the symbol or the name over here, it doesn't actually exist. It's not really a file. It's actually a link saying, hey, you should actually look here at this thing. So whenever I look at Steam PID, it actually goes to this instead. The two files are linked together. And this might give you some questions. One, why do we have symbolic links? That might seem stupid. That's because depending on your program, your shell, no, not your shell, your scripts that you write up, sometimes they look in different places, but they really just want the same thing. For example, I have a Python 3 folder, but I also have a default Python folder. It's like Python default. So whenever I run a command, it looks at the default, and the default just points to the version of Python that I have. So that's when you would use a link. And here it's sort of a similar idea, like sometimes the program just looks at this, but they really want this, you know? But something else that's interesting, here we have an L for link. That's kind of cool. And here, the red one, why is this red? Well, it's red because this file afterwards, I actually deleted. It no longer exists. If I wanted to cat the file, let's do it. What's it gonna say? No such file. It doesn't exist because I deleted it. So now we have this link that points to nothing. And so what happens if I try to cat that? No such file. Yeah, this doesn't exist anymore. It's a link to nowhere. So that's pretty neat. I actually broke my system once because I messed up my links, and it took me like months to figure out, but essentially I was able to figure it out because, hey, I accidentally deleted something that it links to. Another interesting thing, you can also have circular links. Like one thing links to this, which links to something else, which links back to this. If you have that, it's very rare, but I managed to do it because I'm really good at breaking my computer. If you manage to do it, when you try to run it, it'll say, uh-oh, infinite loop, can't do it. So that's another very interesting niche issue. So as you can tell by now, right now we're getting to very random stuff that I just think are interesting. So let's talk about another random interesting thing, which is going to be passwords, right? If I log into a system, it would be nice if I could just see people's passwords. Well, first of all, there's a command called passwd. You can use this to change your password. Whenever you log into a machine where someone else gave you the password to it, you probably want to do this, like the very first thing you do, because if you log in and other people know your password, they can log in as you and mess up your stuff. So change your passwords whenever you can, okay? But I'm not going to do it now because I like my password. Anyways, wouldn't it be nice if there was just a file that had all of our passwords? Guess what? There is. So let's find it. How are we going to find something? Well, there's actually two commands for finding stuff. One is grep. Grep basically takes the output of something and looks for a specific thing. For example, this output is very big. I do not like that. What if I just wanted anything that had to do with Steam? I could do ls-al, right? That's the command that prints all of this junk. But what if I just want Steam? I can grep for Steam. And you see, wow, it tells me only the things that have it. That's pretty cool. There's extra stuff you can do. I don't do it that often. But you can add some lines after. So A1, that's one line after. You can see now, here, it added one line after this, right? Before it was only 3, now it's one more than that. Same thing I could do before 1, and now we add one line before, you see? So that may be good if you need nearby stuff, but you don't see it too often. But anyways, that's for if you have output and you want to look for something specific within that output. What if you don't have anything at all? You just want to see if something is somewhere on your system. You want to try and find something. So let's go ahead and find it. That's our command, find. And I'm going to find. First, we need to specify, hey, where are we looking? Where are we going to start? What's our biggest directory that we're going to search through? And you could just do the current directory or your home directory. But I want to look through everything, so I'm going to do the biggest directory, which is just that. And I'm going to look for the things that are named. So you need this tag name, and then type the name. For example, password. Actually, password is probably how it's spelled. And we could do this. Let's give it a go. Oh no, we get a bunch of permission denied. A lot of permission denied. Why is that? Because we're looking through everything, and we're just a regular user. We don't have access to everything, right? Root is the one that has access to everything. We're not root right now, so we can't do that. I'm going to show you two cool tricks. One is we can just ignore everything that's an error. And so how we're going to do that is I'm going to type this. And you might be thinking, whoa, what's that? That doesn't make any sense. You just threw numbers and characters together. And yes, I did. So this is actually two things in one. First, we have this number. If you just see a number floating around, like it doesn't look like it belongs there. It's just kind of looks like a variable, honestly. That's a special thing in the terminal. Basically, I think 0 is standard in, 1 is standard out, and 2 is the error messages. Something like that. But basically, I'm taking everything that's an error message, all of my 2, and I'm going to feed that. This arrow basically means feed it into this different file, and dev-no. This is just basically anything you put in here is gone. Bye-bye. So when I do it, we no longer get the error messages. That's wonderful. Another thing you could do, you could run as sudo so that you could have permission to everything. But this works. This is great. And we found Etsy password. So let's actually Control C to stop this. And let's go to our big board directory and list everything. We see a bunch of folders here. They all do different things. For example, bin has our binaries, our executables, our programs that we run. Lib has the libraries that different languages use. Home has the home directory for all of our users. And I could keep on going. This is mount and other stuff, but you can figure it out on your own. You know how to Google. Really, the most important one to you is going to be Etsy. Etsy kind of contains all the random stuff that happens to be very useful. For example, here, Etsy password. This is the password file. OMG. I love passwords. Let's go look at it. So I'm going to nano into there. And whoa, we see it. We see all of the users and their passwords. Where are they? So let's break this down. First, we have the user. Okay? This is user root. We have a bunch of other users. This over here is our password. X. Is the password for root really just X? That seems kind of dumb. And it is dumb, because that's not true. This is where the password is supposed to be. And a long, long time ago, Etsy password actually held the passwords for all of our users. But then they realized, you know what? Maybe having a file that contains all of our passwords and allow any user to see that file? Yeah, that kind of sounds like a bad idea. Maybe we should stop doing that. And so they took all of the passwords out and replaced it with X's. So unfortunately, Etsy password no longer tells you what the password is, but instead it tells you some other useful information. Like you have these numbers here. I think that's like a user ID and group ID. Basically tells you what user you belong to and what group that user belongs to. Not super important, but if you want to change what group you're a part of, you can do it that way. This is the name that the user is displayed as. Most of the time, it's just going to be the same as the actual username, but you notice in very weird scenarios like list is kind of weird. You see the name it displays as is mailing list manager. So this is the actual user. This is what you see. Most of the time, it's the same thing. Over here, okay, this is the home directory of our user. You can see root has root. And if I go down to Pukey, you can see, oh wow, my name actually displays as my name. I didn't know that. But we have home Pukey. That's pretty cool. And then finally, bin bash. That's the programming language we use. Basically, when you type in terminal, what language are you using? Where are you getting that from? Most of the time, it's bin bash. If you see no login, that's basically means this user, no one can log in as them. They shouldn't be doing anything. Yeah. And that's basically it. So that's cool. Also, bin false, you can't do anything as that. So yeah, that's pretty nice. You can see all of our users. But, I wanted passwords. Where are all of my passwords at? And it's actually in a different file called Etsy shadow. And if we notice, permission denied, we can't see it. Uh-oh. Well, duh, we don't want everyone seeing everyone's passwords. We can only do it as sudo. Only the root user can see this file. So let's do it. And then, of course, enter my password because it's been a while. Boom! We can see stuff now. And where's our passwords? Again, it's user, password. You notice asterisk for all of these? That's because these users shouldn't have a password. No one should just log in as root or as a daemon or any of these. No one should be accessing it so they don't have any passwords. But for people that should have passwords, like me, yeah, there's my password. Damn, now you probably know my password. But if you saw, it wasn't plain text. It was hashed. So that basically how it works, when you type in your password, it goes through a special math function that changes it into something new called the hashed password. And that's what we store. Every time you log in, it hashes what you type and compares it to the hashed password. So even if you saw my Etsy shadow file, you can't see my actual password. All you can see is the hash. If you're really good at cracking hashes, you can probably figure out what that password was, especially if it's weak. But the point is, this is where our passwords now are, an Etsy shadow, and it's stored as a hash. And you see all of these random numbers here. You're wondering what's that for? And the answer is no one knows, okay? Those don't matter. And so, yeah, that's that. So Etsy has our passwords file, which is pretty cool. It also has some group files, I think, so you can see what groups users are part of. This lesson is getting kind of long, so I just want to touch on one last thing. Let's find cron. Name cron. And I'm going to put asterisks here just to be safe. Basically, an asterisk means anything can be before and anything can be after. Okay? It just needs to have cron in there. And so if we do it, oh no, I'm getting permission denied. Let's sudo this and do it. And we see a bunch of random stuff because I have a bunch of random stuff on my device. But you see Etsy cron. I like that. Let's look at Etsy. Yeah, cd Etsy, my bad. And let's ls and grep for cron. And wow, we see all of these things. What is cron? Why am I talking about this? Cron is how a system automates tasks. So if we look at cron tab, is there anything interesting here? Oh yeah. Basically, it has all of the commands that are running. And you can see here, it tells you how often it runs. So like this one runs every 17 minutes, and it does something. I don't really know. But basically, if you want to automate something, you can put it in here, and that's really cool. And that's all I'm going to say. And that's pretty much everything I wanted to talk about. So I hope this was more informative. I hope you're now comfortable with using the terminal. Definitely get some practice in. It's going to be great. And thank you for watching.